In this video, I'm going to look at how to calculate the relative formula mass of any compound. We'll start with simple examples and then build up our repertoire to more complex ones. A good place to start is by explaining the terminology. In our case, relative formula mass. Let's start with the first word of the three, relative. This is there to remind us that our units for these calculations are not absolute. That is, we are not calculating masses in grams. This is because atoms are so tiny that the numbers we would calculate would be incredibly small fractions of a gram. To get around this, we use numbers that denote the mass of an atom relative to a standard. Our standard is the mass of a carbon atom with 6 protons and 6 neutrons, which is assigned a mass of 12. And that brings us to the thorny issue of units. Because our definition of atomic mass is relative, that is to say, we take a mass of any atom and divide it by the mass of our standard, relative atomic masses have no units. However, you may occasionally see references to relative atomic mass units or Daltons. These are essentially just a label. They are not IUPAC approved units. The second word is formula. Now, for a lot of compounds, this is the number of atoms of each element in a molecule of the compound. However, some compounds don't exist as molecules. Ionic solids exist as giant lattices, but the essential chemical information is the simple chemical formula of the compound. Our third word is mass. This is the parameter that we want to know. I have a video looking at the difference between mass and weight. They are similar but different, and I'll put a link to that video in the description below. Relative formula mass is the correct term, but sometimes this is shortened to formula mass or molecular mass for compounds that exist as molecules. For our simplest example, I'm going to use sodium oxide. This has the formula Na2O. The first piece of information we can take from this formula is that it contains only 2 elements. Hence, we need the atomic mass of each of these elements. The place to find that information is, of course, the periodic table. Now, I'm using one of the RSC's periodic tables. Different tables may look slightly different, but they contain the same information. You will normally see 2 numbers for any element. The smaller one is the atomic number. This will always be an integer. The larger of the 2 is the relative atomic mass. If we look at the entry for sodium, we find that the average atomic mass of a sodium atom is 22.990. Since a molecule of sodium oxide contains 2 atoms, we need to multiply this value by 2 so that we have the total mass of both sodium atoms within the molecule. Sodium oxide also contains an atom of oxygen, so we look that up in the periodic table to discover that it has a mass of 15.999. So we add that to the mass of the 2 sodium atoms to get the total mass of the molecule, 61.979. Now let's be very clear here. This is no different to calculating that if you have a kilo of apples and 2 kilos of pears in a bag, the bag will contain 3 kilos of fruit. The fact that we're looking at atoms rather than fruit makes no difference to the maths. It really is that straightforward. Therefore, we're ready for a more complicated example. Here's the formula for aluminium hydroxide. It's a bit more complex than our previous example because it contains brackets. The brackets denote that those atoms are found together in the molecule, and that in this case there are 3 such groups of atoms. For our purposes, they're just like when we use brackets in maths. we have to do the calculation within the brackets first. Just looking at the elements with the brackets to start off with, we have one oxygen atom, so we can look that up in the periodic table, and its relative mass is 15.999. The other element is hydrogen, which has a mass of 1.008, and again we only have one atom, so the total mass of what's in the brackets is 17.007. So far, so good. But if you look at the formula for aluminium hydroxide, you'll see that there are 3 of these hydroxide units. All we have to do to account for this is to multiply the result of our addition by 3. Now we've accounted for all the atoms in the molecule, except one, the aluminium. So back to the periodic table, and we find that the relative atomic mass of aluminium is 26.982. We add that to our calculations and find that the relative formula mass for aluminium hydroxide is 78.003. By now, you're up to speed with most of the necessary information for calculating relative formula mass. However, there is one extra little piece of information. And to illustrate this, I'm going to use a compound that you have probably seen in your chemistry lab. This is the full formula for those lovely deep blue crystals of copper sulfate. If you crystallize copper sulfate from a solution in water, some of the water gets trapped as the crystal forms. Fortunately, the structure of the crystal is such that exactly 5 water molecules are held in the crystal for every formula unit of copper sulfate. That is why the full formula for such crystals is CuSO4.5H2O. For the purposes of our calculation, we can treat the 2 halves of the formula separately and then combine them. Let's start with the copper sulfate itself. We only have 1 atom of copper in the formula unit, so we look that up in the periodic table and discover that it has a relative atomic mass of 63.546. Next, we look up the relative atomic mass of sulfur, which is given as 32.06. And finally, we look up the relative atomic mass of oxygen, which is 15.999. However, we can see from the formula that there are 4 oxygen atoms in copper sulfate, so we multiply this by 4 and then add up the numbers to give an answer of 159.602. Now this is the relative formula mass of copper sulfate, but without the water molecules of crystallization. This form of copper sulfate does exist, but it's not the form we wish to use. Some more calculations are necessary. Now we consider the water molecules. They contain hydrogen, so we look up the relative atomic mass for that element, and it's 1.008. Each water molecule contains 2 atoms of hydrogen, so we multiply that figure by 2. Water also contains an atom of oxygen, so we look that up and it's still got a relative atomic mass of 15.999. We add these together to give the relative formula mass of water, which is 18.015. Now there are 5 water molecules in each formula unit of copper sulfate, so we take this result, multiply it by 5. Now we can combine these masses to yield the overall relative formula mass, which is 249.677. Now it's very easy at this point to think that the calculation is finished. However, did you notice that all the relative atomic masses used were shown to 3 decimal places except 1? The figure shown for sulfur is only shown to 2 decimal places. The 3rd decimal place is not accurately known. This level of inaccuracy affects our final answer. We cannot quote that last decimal place as we don't know it, so we round our final answer to 2 decimal places to yield 249.68. These are all the steps needed to calculate the relative formula mass of any compound. Of course, for complex organic compounds, the calculations are going to be a bit more lengthy, but they will use exactly the same principles that I've just shown you.